Okay, class, we last looked at the law of sines that helped us out with the first two cases that we discussed. In order to deal with these case 3 and case 4, we're going to employ the law of cosines. So let's just look at how we can pretty much build the law of cosines for ourselves once we understand the structure here. So it looks like these are pretty complicated, but when you think about them as English sentences, they're not so bad. So you'll notice what happens. Let's start with the square of one side. So I'll take any side, and in this case, say we started with the C side. So we're going to take one side and square it. And then we already know what to do. We're going to add the squares of the remaining two sides. So we'll just take the squares of these remaining two sides, add them together, and the last thing we do is subtract double these same two sides product. So, and then the only thing to remember after that is to multiply that by the cosine of the angle that corresponds to the opposite of the side C. Okay, so C is going to be on the extremes. On the extreme right is the angle C, and on the extreme left is the side length squared of C. And so just duplicate that. Since these are all arbitrarily placed anyhow, it's better to think of the pattern that's happening. The pattern is that once I allocate a side length squared to the left-hand side of this equation, I then know that the other two sides are going to be squared and added, and then double their product. We'll subtract. We're always subtracting. Double their product times the cosine of the angle that's associated with the side on the left side of the equation. So if I wanted to build that from scratch, and we're starting with A, I'm going to take A and square it, and I know that equals to the sum of the squares of the other sides, so C squared plus B squared, and then minus twice the product of C and B times the cosine of capital A. Okay, so I wasn't looking at this and able to build this just because of the concept that the square of one side equals the sum of the squares of the other two sides minus twice their product times the cosine of their included angle, which is just the angle opposite the side that we started with. So we started with C squared and so on. So we get A squared plus B squared minus twice AB times cosine of big C. Okay, here's an interesting little exercise with the law of cosines as it pertains to a right triangle. Most of us have encountered Pythagorean theorem. Okay, and the Pythagorean theorem says that if I have a right triangle, that the sum of the squares of the legs is equal to the square of the hypotenuse. So let's just rewrite our law of cosines in terms of this length C that we call the hypotenuse in a right triangle. So we'll make that the left-hand side of this, and then we know that the law of cosines take the sum of the squares of the other two sides. So we'll put the A squared plus the B squared, and then we subtract twice the product of A and B times the cosine of the angle opposite whatever is on the left-hand side, C, and we know that that's a 90-degree angle. And then since this part of the factor is 0, we're subtracting 0, and we land right back at the Pythagorean theorem. Okay, so here we've got example 1 has a triangle described for us, and we want to solve the triangle completely, just given the parts that we know, and it's always helpful to draw a little sketch. So let's say that we've got A's side length over here, and B down here, and so B is a little larger than A, so we'll make that 2 and 3. And then C must be this length here, whatever this is. Okay, so the parts they gave us were A, B, and the angle opposite length C is 60 degrees. Okay, and since 2 is opposite angle A and 3 is opposite angle B. Okay, so the way we'll start with this is the C's we don't know, but we know that angle opposite it. So C squared is equal to 2 squared plus 3 squared minus twice the product of 2 and 3 times the cosine of the angle opposite the length C, which is 60 degrees. So C squared is going to be equal to 4 plus 9, so that's going to be 13, minus 12 times the cosine of 60 degrees, which is 1/2. So C squared is 13 minus 6, 7. So if C squared is 7, then C is equal to plus or minus the square root of 7, but we're calculating a side length, so we're only concerned with the positive result. And so now we need to find the angles for the rest of this. So first, let's just replace that C with the value of C, which is the square root of 7. So let's make C the square root of 7. And remember this thing, it's a little hard to read. That's 60 degrees here. So we still need to find the angles for B and A. So let's plug into law of cosines, and let's take the 3 first. So we got 3 squared on this side. So I know at the end of my law of cosines, I'll be putting times the cosine of angle B. So 3 squared is equal to the sum of the squares of the opposite the other two sides. So that's going to be 2 squared plus the square root of 7 squared minus twice the product of 2 and square root of 7. And then all that times the cosine of B. Okay, so we end up here with 9 equals 4 plus 7 minus 4 square root of 7 times the cosine of B. Alright, so we'll just simplify this until we get the cosine of B on one side by itself. So 9 equals 11 minus 4 radical 7 cosine B. And so we're going to subtract the 11 from both sides, and we'll end up with negative 2 equals negative 4 radical 7 cosine B. Okay, now we want to divide both sides by negative 4 times the square root of 7. Alright, so putting cosine of B on the left-hand side by itself, we know the cosine of B is equal to 1 over 2 times the square root of 7. Now, normally we would want to multiply top and bottom by a square root of 7 so that the cosine of B is equal to the square root of 7 over 2 times 7, or 14. So that would be simplified proper radical form, but it really wouldn't matter if we're going to have to use the calculator in the first place. So we're going to find the inverse cosine of the square root of 7 over 14. You could also have just fed it 1 over 2 times the square root of 7 and not have rationalized this in the denominator. Okay, so we're wanting the inverse cosine of the square root of 7 over 14. Make sure you're in degree mode. And this comes up with an angle to the first decimal, 79.1 degrees. Alright, so since the cosine of B is equal to the square root of 7 over 14, B itself is equal to the inverse cosine of the square root of 7 over 14, and we found that to be roughly 79.1 degrees. Okay, if I wanted to, I could set up yet another law of cosines and solve to find the angle B, and that would be in the case where we take 2 squared on the left-hand side. So that equals the sum of the other side's squares, so 3 squared plus the square root of 7 squared minus twice 3 times square root 7 times the cosine of the angle A that's opposite the 2 that we squared. But we don't have to really do all that work because we already have 2 of the interior angles, so we know we could also find it by taking 180 and subtracting the 60 degrees they gave us and subtracting the 79.1 degrees that we found. And we should get a result there of about 40.9 degrees. It's a little easier than building this out and solving for an inverse cosine. Okay, so the final angle is 40.9 degrees.